Yeah, thanks, Willis. I'm Ethan. I'm a first year PhD student at MIT. I was a 2024 scholar.
Who's next? Should I go next? My name is Paulina Vargas. I'm a 2024 Goldwater Scholar, and I'm also a pre-doctoral first year student at the University of Pittsburgh.
Hello, my name's Madeline. I'm a first year PhD student at UT Austin. I'm also a 2024 Goldwater Scholar, and I study physics, condensed matter physics.
Hi everyone, my name is Arjun. I'm a 2023 Goldwater Scholar. I'm a first year PhD student at Harvard Medical School studying virology.
Okay. One of our panel is having technical difficulties, but other than that, everyone is here. And so Ethan kindly agreed to present a short presentation on the anatomy of an abstract. And so hopefully he can share his screen.
Yeah, let me go ahead and do that. Okay, give me 2 seconds. Okay, can you guys see this? Good. Okay, cool. So this is just a quick, I'm going to take 4 or 5 minutes here, and we're going to outline the anatomy of an abstract, what it looks like, what it should include, and then I have a couple of examples here as well. So, to begin, I like to think of three main parts of the abstract. Those are going to be an introduction, a summary of your findings, and future work or implications of the findings. Um, Really, if you have these three and they're well outlined and detailed, your abstract is pretty good. So, what do I mean by an introduction? Basically, why does the reader care about what you have written or what you're going to present based on your abstract? Is it important to certain fields? Is it important for an engineering application? Um, what does, what's the point basically? What are we getting at here? What was the purpose in starting the project? And once you move in from that, you want to transition to a summary of your findings, and this is very explicit. What did you find out? If you made a new system, what was the advancements that were made? If you made a big discovery, how or what was the discovery? Outlining that, quantifying those findings and how you made them. Um, you want to have a last sentence again about how you made the findings. It doesn't need to be extremely in depth because that's what the presentation is for. But a quick sentence or so, we had these findings. We were able to quantify them using this method or that method, or so on and so forth. And then you want to have an implication section. This is, in my opinion, the most important part. It kind of draws back to the introduction again. So, in the introduction, you've talked about this type of work is important. In your summary of findings, you said, we discovered this new thing, we made this new thing, and this is briefly how we did it. And then the implications, it kind of goes back to, okay, how does this solve the original problem? How does this advance what we first talked about in the introduction? So here I wrote down, how do your findings overcome the problems? Have your results also previous knowledge? And using the findings, does somebody benefit from it? Because again, if you put in findings, but it's not clear why they're important, then the findings don't mean much. So I wanted to show a quick example here. This is from a paper. And so this is kind of going through those three steps blocked out here. You can see different colors. So in blue, we're going to go through our introduction, and I'm just going to read this really quickly. It says gold nanoparticles have become increasingly useful in recent years for their roles in nanomedicine, cellular biology, energy storage and conversion, photocatalysis, and more. At single particle level, gold nanoparticles have heterogeneous physical and chemical properties which are not resolvable at ensemble measurements. So this is outlined why what we want to study is important. So here the author said gold nanoparticles are important and they're used in this discipline, this discipline, this discipline. However, there is a problem because they're not resolvable in ensemble measurements. And then we move into the findings. So that's what's going to be highlighted in red here. In the present study, we developed an ultra-high throughput spectroscopy and microscopy imaging system for characterization of gold nanoparticles at the single particle level using phasor analysis. The developed method enables quantification of spectra and spatial information on large numbers of gold nanoparticles with a single snapshot of an image. And then I have this bolded here. That's like a quantification. You want to make sure that you're quantifying things in this part of your finding at high temporal resolution and localization precision. We characterize the localized surface plasmonic resonance scattering spectra of gold nanoparticle or nanospheres, excuse me, of 4 different sizes. So you can see in the findings section here, we have outlined basically what our advancement was and then briefly how it was done. So it mentions here that the phasor analysis was used and we got this resolution with this time scale, so on and so forth. And then lastly, we have implications. So after the authors here wrote about the findings, they then move on to implications and say comparing to conventional optical grading methods, which suffer low efficiency in characterization due to spectral interference caused by nearby nanoparticles, the phasor approach enables high throughput analysis of single particle SPR properties and high particle density, up to 10-fold greater efficiency of single particle spectral microscopy analysis using the spectra phasor approach when compared to a conventional optical grading method was demonstrated. So basically what the authors are saying here, in the introduction, gold nanoparticles are important, but we have this problem, we're not able to resolve them really well. Then in findings, it's okay, we came up with a method that can resolve them pretty well. And here are specifically what we were able to resolve there. And then lastly, we have this is important because there is another method and our method's better. And basically also quantifying that saying we have 10 gold, or the author said we have 10-fold greater efficiency than this other conventional method. So this abstract has all three parts of the introduction, findings, and implications. And then very quickly, I'm going to go through a poor abstract. So I'll just read this one aloud. Gold nanoparticles are widely studied in many areas of science and technology. Various methods exist to analyze their properties, and some are better suited for certain applications than others. In this work, an approach involving spectroscopy and microscopy was used together with image analysis techniques. The system captured detailed information from samples and allowed for a range of measurements. Several types of gold nanoparticles were examined under different conditions using the setup. Comparisons with other methods were made, and the differences are noted throughout the study. So in this type of abstract, for one, the introduction section, if you can call it that, it all kind of blends together. But it's too vague. So it says gold nanoparticles are widely studied in many areas of science and technology. In the introduction section of our anatomy here, that's too vague, and it doesn't specifically name what we're getting at. And then the findings. So in our findings section of our anatomy, there's not quantization here. There are no specific numbers given or anything like that. And then finally, in our implications section of the anatomy, we don't have any comparisons to how we advance things or what can be done going forward. So that was a very quick presentation just on the anatomy and outline of an abstract. And I think Wimith, go ahead and take it from here.
Yep. So anyone have any questions for Ethan? Okay, I guess not. So we can get started with the panel discussion. So a really big issue that some people have, especially with GCURS, which is so close to the summer where people might have been doing their research, is getting started writing their abstract. So question for the panel, how do you get started in your abstract writing process, or how do you begin?
I think when you're writing any type of scientific literature, it's important to convey what type of story you want to tell, right? So think about the biology or whatever field you're looking at. What problem are you solving? Where are you exposing the knowledge gap? And also, crucially, and the same thing applied when I was writing my Goldwater application, why should anyone care about your research? If you can prove those key points, I think you have a great framework to start writing.
Yeah, I totally agree with that sentiment. I think the most important part of the abstract is definitely outlining, again, kind of why we care. Why is the work important? Even if the advancements are not substantial, you didn't make a Nobel Prize winning discovery. If you can clearly outline why you did what you did, why it's important, and how it's progressing science, then it's a very strong abstract.
Yeah, I want to just echo the exact same thing that the other two have been saying and be a little bit more like when it comes to your abstract, most people are only going to read the first couple sentences and the last sentence, the implications as Ethan outlined, and then like the why should we care. People in your field will be familiar with like for instance, with the gold knot nanoparticle stuff, I kind of knew what was going on there, so I really valued that technical detail, and it should be there because you are trying to, convey yourself as a scientist and try to explain your work, which requires technical language. But most people probably didn't know what half that jargon meant. But everyone should know what the first couple sentences and the implications are. So really narrow down on the first two and the last.
That's good advice. My advice to how to start an abstract is just begin by outlining and knowing who you're going to be presenting to, where you're sending your abstract to. Know where they're getting their funding. That way, you know what direction to present this literature or this gap in the literature within those first two sentences. And start by writing 2 or 3 sentences for each, like your introduction, and then your methods, and then your results, and then your conclusion and discussion, and keep just have a solid outline and a rough draft prior to condensing it and reviewing it after.
Okay, so once you have that outline or you've gotten started, how do you generally expand your abstract or start to develop it beyond just an outline or just those initial drafts?
This is going to be personal for everyone, but I find that when I make an outline for an abstract, my biggest challenge is actually taking away information as opposed to developing it. Really nailing down what is the most important results, what is the most important technical details, because it's really easy to talk about your research and talk about every single detail, but an abstract is not the place to do that. So for some people, it's going to be actually mostly figuring out what the most important information is. And sometimes the best way of doing that is talking to other scientists that are not necessarily in your field, or talking to your PI because they are or your graduate student mentor, because they are very experienced with writing these pieces and talking about what is needed, what is not needed, etc.
Yeah, I totally agree with Madeline. For me as well, it's the most difficult part is finding what's important to keep in the abstract. It's very easy to write everything because yeah, I mean it's your work. Of course, you want everybody to know everything that you did and all the results you found. But it is again, it's audience dependent. Um, like a lot of people, again, what Madeline said in my presentation, a lot of people maybe don't do spectrum microscopy. They don't they don't care that it was 26 frames per second. They don't know why that's important. So really hammering down the details that the audience is going to understand and they're going to take away. That's the most important thing from writing the whole abstract is somebody learning or taking something away from what you've written there. And you want to do that as concisely as possible.
The method that it just personally works for me is after writing those 2 or 3 sentences for each section of my abstract, I condense those sections to one sentence, and then I work on transitioning from those sentences. And after that, I just have a solid rough draft of an abstract that I can then compare to other abstracts within my section of science. Like, let's say it's social science, then I just, compare it with other people in the field, and I ask my peers, and I ensure that my peers outside of my field of research understand the main objective of the research that I'm presenting prior to telling my PI, and then so it's just like a review process after that.
Yeah, echoing the others, I really think it's an iterative process, right? It's a dynamic document until you submit it, at least. It's going to get better and better over time. And I think word vomiting at the start is totally.
So, if you do word vomit a lot and you need to cut it down, what do you do if you have trouble cutting it down or if you get in like a writing block or cutting block in this case?
This is when doing stuff ahead of time is very important because then you have the luxury of just not thinking about it for a while. So I would say just try to just take a break. If you can't take a break and it's like do in one day or do that night, I would recommend just taking a mini break and just accept that it's probably not going to be perfect and what matters the most is submitting it.
I think for me, what is the easiest way to kind of condense those things once you've got the outline really, you know, it's meaty, okay? Like it's a large abstract. The easiest thing that you can do is take out words that are unnecessary, filler words, condensing things, um, stuff like that's very easy to do. And oftentimes it doesn't get you exactly to the size that you want your abstract, but it can do a whole lot for you. Once you get past those filler words and doing some grammar tricks to make things a little shorter and more concise, I think that's when the hard decisions begin about what results do I want to say specifically here and what can wait until the presentation. So for that, usually you take what is of highest importance. And that, of course, is subjective. So usually you would take what is of highest importance to you. You could also do, what do maybe your PI or what do the grad students feel is highest importance to the field? If you had multiple small discoveries or something like that. Um, but I would advise outlining in this type of abstract what result is most important to you and just having one clear result there. And that can take out a lot of that kind of the flesh of the abstract and really make it more concise.
Would the rest of the panel like to add anything?
Yes, in my opinion, it helps to focus on the flow of information as well, to know that somebody else can regurgitate the the process that your study follows. So you have this gap in literature or your main topic at hand, and you follow that with a sentence describing why this particular topic needs further studying. And then you address, okay, well, to do this, we did this. And then you explain in the following sentence, more specific what the methodology was. And then you can just state, we found this. And then following sentence, these outcomes are, particularly something, a synonym for, why there's relevant or discussion. And it's just keeping that flow maybe alleviates the stress of having to cut off certain prepositions that act as filler words.
Arjun, anything you'd like to comment?
No, I think you guys said it well.
All right, and kind of jumping off of that, are there any reasons that you kind of skip over parts of an abstract or parts of an abstract you really don't like or that you've read in other people's abstracts that just kind of distract you from the main point?
I think one thing is you really want to follow the science, right? This story. It doesn't matter so much what buffer you use or how long you were in a gel. It's more so what's the biologically relevant question. That can be applicable to people not just in your field, but people that are maybe interested in a similar model as you, even transversing fields. So don't get too bogged down into the details, like when you talk about methods, results. Make sure everything's relevant. So if you use a method, why is that relevant? What does that method allow you to do that other methods may not? That way you keep it interesting, you keep it light enough, and then some of the more details about your method you can get into your presentation. Now, obviously, if your talk is about developing a method, perhaps that warrants further exploration. But for more like hypothesis-driven questions or have like a biological focus or focus in other fields, I think stick to use like the methods as a tool to answer your scientifically relevant questions.
Yeah, I think that's probably the most important point. For instance, in my field, we work in superconductors, and to analyze the superconductors, we have to make some really cool, really awesome spectroscopic instruments, and that's what I love. But in an abstract like this short, I know that the focus needs to be on, we learned this about this new superconductor, and that's what's scientifically relevant. If I was to write my abstract, I built this really cool instrument, it does this and that and blah blah blah. That kind of defeats the purpose of the scientifically relevant part was this new superconductor that we observed, or something in a similar field that you would have. So there are a lot of parts that you may want to talk about, and in a presentation you can talk about absolutely. But in the abstract, you want to focus more on one big scientifically relevant question that you answered or method that you came up with, something like that.
I would say it's also important to keep in mind that not everybody reading the abstract is going to understand the technical jargon. So something that may drive me to not read a full abstract, with full excitement is that first sentence doesn't have a clear statement or objective, and it's not following this like a logical, concise flow. So that first sentence really has to encompass the key concept or overall theme of the research.
This is something that primarily people who write their first abstracts, which many of you guys may be in the boat of doing right now, fall into a trap with, and that is they make their motivation section a little bit too long. An abstract is very succinct, and the motivating sentence, as Ethan pointed out in his example, should be a couple sentences or one sentence. And sometimes I read, especially when there's like larger word limits, like a paragraph. And you can write a paragraph of motivation if you really highlight like the scientific relevance in that paragraph too. But it shouldn't be like this it shouldn't be like a very broad motivation. You should really have a broad motivation and then start diving into the results and the scientific relevance.
All right, and a question in the chat which is very close to this, from Cade, and it's already been partially answered by the panelists, is that they have a good grasp on the intro and the impact of their work, but they don't have a lot of positive results yet. And so could the rest of the panel help Cade figure out how they can reframe their finding section if they don't have a lot of positive results?
I think me and Arjun, I think it's funny actually. We both were typing at the same time. Apparently, we sent these messages out, and they basically say the same thing, which is even if you have negative results, or I don't know exactly what is meant by you don't have positive results, but if you have something that's negative or you're still working on something, that is still a result. And so that still definitely belongs in the findings section. Even if, in your opinion, it wasn't a good outcome or it's not the outcome you expected, it is still an outcome that was observed. And that kind of work is still important to know. Um, and I think it's perfectly fine to say, I had trouble with this. And so in the future, I'm trying this thing. You know, um, it is difficult to write about ongoing work. Um, just from personal experience for me, it's difficult to write about ongoing work, but that is a good way to do it. And it conveys, what am I trying to say? It conveys kind of a desire to continue the work, which is really attractive to a lot of people, myself included. I like reading stuff where people are like, we're having this problem, but we're going to keep pushing. We're going to try this, that, the other. Personally, I like reading stuff like that. And I think it is actually a good way to write an abstract if you don't have a lot of results for outcomes that you wanted to personally see.
Also, I think you might mean when you talk about positive results, results that kind of agree with your hypothesis. But remember that you're not trying to prove a hypothesis is true or not, right? You're just trying to see what's out there. And if your results go against the hypothesis, maybe it's time to reorient that hypothesis and ask, what might that mean about the system? Or what might your data be telling you that your initial proposal may not have included?
Yeah, I can kind of agree there. I mean, the point of doing science is not only just discovery, but also to prove yourself wrong. And you just keep reiterating that, and you are in this case, the expert of your own science. So if people are asking you, you can always redirect and say, you know, as this objective is following this direction, I hypothesize then this, and it's a great opportunity to just speak further on details corresponding to the project, but a result is a result in and of itself. You found XYZ, and that does mean something.
Yeah, and I also don't know exactly what's meant by like positive results, but for example, in my GCURS abstract, I highlighted about how my research was trying to aim at figuring out what packing morphology separated charge carriers, but my research actually proved what didn't separate charge carriers well, and I couldn't find a packing morphology that did so efficiently. And I could only hypothesize still on what would make a good one. And I was able to go and, what was important was that it was found out, like what didn't make a good charge carrier material. So I wouldn't like if it doesn't go with your original hypothesis or your original goal, it doesn't mean it's bad.
Oh, okay. So they found that helpful, so that's great. Okay, one of the final questions is how do you make your abstract very memorable? So we've kind of already gone over the pitfalls of how abstracts can kind of fail to gain someone's attention, but what do you see in your own abstracts or what do you see in other people's abstracts that really catch your attention and make you go, oh wow, this is a great abstract, or I'm really interested in what this is talking about?
I think the biggest piece of advice I have, not just for abstracts, but the Goldwater proposal, my MSF proposal, my grad school apps, is when you talk about science, always use your methods to answer a question. So, for example, in my lab, we run a lot of gels. So don't say, I ran a gel to understand if protein X interacts with protein Y. You want to lead with the science, right? So you want to say, I was interested in understanding if protein X and Y interact. Therefore, I did X method. I think that crucial detail, every single sentence, make sure it has that because that shows that you're leading with the scientific thought process and then you're finding tools in your inventory to answer those questions.
Yeah, I think that is the main point here. Kind of like in my work, I mentioned that I work on superconductors, but most of the work that I actually do in the lab is building these instruments. But when I write stuff relating to this work, I don't say, I built this cool instrument because I wanted to look at this. I say, I discovered this new thing, or I observed this new thing in this superconductor, and this is how I did it. And so, in terms of writing an abstract, it's kind of like in the presentation when I was talking about introduction, you always want to start with the science. So, why is it important? What did you observe? Things like that before you get into this is what I did to get that result.
And just to follow up, the way I thought about it, and this is true to a point, anytime you apply for anything, right, even grad apps, NSF, you're writing a grant. So you're asking people to fund you or support you. So why should they care about your research or why should they give you funds or support? Not to do an experiment or like not to develop tools, but in my case, it's to understand HIV, to help cure HIV. And that's what you want to get at. You want to make them care. And I think that sentence structure, like you've been saying, helps them.
Yeah, they couldn't have said it better. I was what makes it an abstract level for me is the big emphasis on methodology because that is what I'm reading. It's the capability of this study's experimental design. That's what's capturing me. That's what makes it unique. And so focusing on that is really just the biggest like implication. I find that maybe using words like novel or modification of this or synonyms of making your methods unique is particularly interesting. And also diving into results early on in the abstract, I think has also been pretty memorable to read.
Okay. And so all of you attended GCourse previously, and you all agreed to join this panel. So I'm hoping you had a good time. Would you like to let the audience know about a great experience you had at GCourse or why they would benefit by attending?
Yeah, so for me, prior to going to GCURS, I had been to some other conferences and done posters and given talks and such. What is unique about GCURS, first of all, is that everyone's giving talks. And I will say, I believe a lot of you that are interested in this are interested in going to either a professional school or PhD, something like that. And number one, that's a lot of people, a lot of admissions committees like to see that. That you've given talks before that, that has kind of like a prestige to it that people like. So that's kind of an interesting aspect. Additionally, what I found so interesting about GCURS compared to other conferences is that you're surrounded by, you know, I forget exactly how many it was, but a lot of other undergraduates that are in the same position you are. And so it's really nice to be able to piggyback off each other's ideas, make friends, and make connections in places that you may not have thought you would be going. So for me, I mentioned briefly that I'm at MIT now. Um, Actually, one of the deciding factors in pursuing this was someone that I met at GCURS. I didn't know anybody from New England area at all, and I actually met quite a few people that were from institutions around here, and they told me a lot about it and a lot about the work they're doing, and that kind of, drove me to this decision. So, I would say the biggest thing for me is the people there, meeting and talking to everyone.
It's also a really unique format. You're not having a typical poster presentation. It's you are up on a podium and you have a PowerPoint and you have the attention of a room on you. And it's great practice for, let's say, in your doctoral studies, when you're defending your thesis or proposing your thesis, you understand the environment and maybe the pressure or just the overall energy that it takes to fulfill that. And it's also really exciting, and you have this intimate connection with the audience where you can read them. It's just a great practice for presenting. You also get to know the campus as well, so if that's a potential school that you want to see and measure the energy of as well, you can see that. That's what made my experience just particularly amazing. It's just really new format, and you get to meet lifelong friends and see other research within fields that you're already interested in. You're broken off into sections. It's just such a unique environment.
I think a big part of conferences are just social ones, and all the ones that I attended were like full of like postdocs and grad students. So it was really nice to just connect with other undergrads who are all going through the same thing, which is really nice. And then, like others were saying, you'll notice that like you often see the same people again and again. So like when you go to interviews, like you'll probably see some familiar faces, and it's nice to kind of make those connections to the degree possible, even at GCUS.
I found that the talk itself, any talk practice, like anytime you give a talk, it's going to build up your confidence in speaking and your ability to communicate your research, no matter what. But I found that particularly GCURS was really good at making me think about what was necessary, kind of analogous to abstract writing, because beforehand I had only presented to other experts within the field or just my own lab group. So I really, I had some major revisions when it came to communicating the big ideas. I redid my slideshow many times, and it made me proficient. Like previously, I thought, oh, you just talk about your research and the slideshows would be very similar, but I realized that there's very different types of, there's a colloquium style presentation versus a seminar presentation, and I was able to build my muscle in presenting both through GCURS because it was the first time I've ever did that. And that was very valuable because it helps you with talking to also like professors that are not exactly in your field and other peers, and it builds up your ability to be part of a scientific community.
We also have Caitlin here. She is the co-chair of the conference committee, and so she can say a few words specifically about how great the Goldwater Summit is.
Yeah, thank you, Wimeth, and thank you all for sharing your experience. I definitely agree with what all the panelists have said about the benefits of attending GCURS. In particular, like Madeline was saying, it's different to present to a whole group of people who might be in maybe your same field, but completely different subfields than it is to present just to your lab group or maybe in other experiences in your classes. So I think that that's really a huge benefit. You can present to all different people, including faculty and other students, and you can get some really good feedback. You can get individual feedback from the faculty mentors. So the presentations are a really great opportunity. And also, we will be having several Goldwater Summit events. So there will be a dinner where Dr. Matea, the president of the Goldwater Foundation, will be there, and a lot of other Goldwater scholars. So that will just be a great time to socialize and network. We'll also be having a social event and a fellowship panel on Sunday, so you can learn about different fellowships that you might want to apply for in the future. And yeah, in general, it's just going to be a really fun weekend. Some of you might have been there last year, and I think this year is going to be even bigger and even more fun. So please apply and feel free to reach out if you have any other questions. Don't forget to come to the next several webinars as well.
Okay, so now it's time for all the people in the audience, if you have any questions, to ask our wonderful panelists. Yep, if you have any questions. Otherwise, we will then move to the workshop portion.